Hi, this is Dr. Rickert, and this lecture is on intelligence. I'm not going to go through the whole chapter on intelligence. I'm just going to talk mainly about historically, how they developed the first intelligence tests, and then go over some of the more modern theories and different ways of looking at intelligence. Okay, so first of all, what is intelligence? Different people have different definitions of intelligence. They tend to agree to some extent, but the one that's in the textbook, and so the one we'll be using, is intelligence is the ability to use one's mind to solve novel problems and learn from experience. So intelligence, we've always had the concept of intelligence, but it wasn't measured until the late 1800s, early 1900s, and the developer of the first intelligence test was a French man named Alfred Binet, and it was later modified by Theodore Simon, so it's sometimes called the Simon-Binet test. Binet was French, and the French government wanted him to invent a test. He never meant to measure everybody's intelligence. They wanted him to invent a test to be used with children who were having a lot of trouble in school, or children who were below average, or sometimes way below average, to try to categorize them and try to figure out, how much can this child learn? Should they go to a regular school? Should they go to a special school or something like that? But his goal was to measure aptitude as opposed to achievement, because they already had achievement tests. An achievement test measures how much you have achieved, so how much you've learned. So most of the tests you take in school would be called achievement tests, because you learn something and then you're measured on how much you've learned. What Binet wanted to measure was not how much somebody had learned, but how much aptitude they had for learning in the future. How much can they learn in the future? So that's what an aptitude test is. It's supposed to be pretty much independent of what you've learned in the past and be used to predict what you can learn in the future, although many studies have shown that how much you've learned in the past does in fact affect how well you do on these tests. But his goal was to predict how well these children would do in the future. A man named William Stern coined the term mental age, which is the idea of where are you mentally? So, for example, a 5-year-old child who is really smart and is able to think like an 8-year-old child would have a mental age of 8, even though their chronological age is 5. So your chronological age is your real age. Your mental age is the level at which you're able to think. And so Lewis Terman developed the modern IQ test, which is the ratio of your mental age divided by your actual chronological or physical age. So like I said, if a child is 5 years old, her chronological age or physical age is 5, but if she's really smart and is able to perform on a test the way an 8-year-old would, her ratio IQ would be 8 divided by 5, and then you multiply it by 100. The deviation IQ is pretty much the same thing. You divide a person's test score by the average test score of people in their same age group and multiply by 100. So for example, 8 divided by 5 multiplied by 100. And if you are average, your test score will be the same as the average person. So your test score divided by the average test score will be 1. You multiply by 100 and you get 100. So 100 is the average IQ. If you're above average in intelligence, you will score higher than 100. If you're below average, you'll score less than 100. And these tests have sometimes been used to predict performance in school. They do predict performance in school to some extent. And there are 3 main intelligence tests that are most commonly used. There's a lot of different intelligence tests out there, but the 3 most commonly used, the Stanford-Binet, named after Binet. Some people at Stanford University modified it, and they came up with the Stanford-Binet intelligence scale. Then the other 2 are the Wechsler tests. There's the Wechsler Adult Intelligence Scale for adults and the Wechsler Intelligence Scale for children. And the Wechsler tests measure intelligence by giving you a number of subtests, because they know that you can't have just one test for intelligence. You need to test a number of different things. So this is an example of the Wechsler Adult Intelligence Scale. It has a number of subtests. There are some verbal subtests where you have to define words or say how words are similar to each other. There's some more what they call the performance scales, which are more visual spatial in nature. There's one where you have to put puzzles together. There's one called block design. I think this slide shows you the block design. You have a number of blocks that have red on some sides, white on some sides, or some are half red and half white, and you are shown a certain design and you have to recreate that design, and you have to do it as fast as you can. It's a time test. Okay. And so then they take the mean of all these different subtests and put them together, and that gives you your IQ score, again with the mean of 100. If you're average, you'll score 100. So there is a normal curve of intelligence on pretty much any intelligence test they've come up with. There's a normal curve. You may remember the normal curve from earlier in the semester. I think it was chapter 2 when we talked about research methods. And it's a frequency histogram. This is the number of people, and these are the IQ scores. So these are the IQ scores down here. These are the number of people who get those scores. And most IQ tests have been normed so that the mean is 100. And the standard deviation is 15. So you may recall from the normal distribution that if you have a normal distribution, most people will score in the middle, and it's symmetric. There's an equal number above the mean and an equal number below the mean, and a smaller and smaller number of people. As you go farther and farther out on the scale, you have fewer and fewer people in there. But you do have a very small number of people who score really high and a small number who score really low. So because the mean is 100, the standard deviation is 15, and you have a normal distribution, what that means is that about 68% of the population will score between 85 and 115. About 95% of the population score between 70 and 130. If you get an IQ score greater than 130, you are in the upper 2% of the population. Similarly, if somebody has an IQ score less than 70, they're in the lower 2% of the population. And since it's almost Halloween, I thought I should probably show you the paranormal curve of intelligence. So that was the first original idea of intelligence, the idea that it's just one thing that can be measured by this one test, or it's actually a number of subtests if you're using the WAIS. But other people have other ideas about what intelligence is. One of the very influential people is called Charles Spearman, and he actually did something called factor analysis, which is a very complex thing that I'm going to try to very briefly describe to you. You'll recall from earlier in the semester we talked about correlations. If you give people two different tests and you graph out how they score, so this is one test down here and this is another test here, each of these dots is a person. And so this is a scatter plot showing where each person scored on both of the tests. If you have a positive correlation, the dots will fall along a line that slopes upwards. That means as you score higher on one test, you will also tend to score higher on the other test. That's a positive correlation. You can also have a negative correlation, whereas you score higher on one test, you score lower on the other. When we're talking about intelligence tests, we don't really consider the possibility you could have a negative correlation, because you pretty much never do see a negative correlation. But you do often see positive correlations. If you give people two different tests of intelligence, you will find a positive correlation between them. That is, that people who score high on one of them will also tend to score high on the other one. In factor analysis, you don't have just two tests. You have a whole bunch of tests, and you take the scores on all these different tests and look at how they all intercorrelate with each other. And you put all these scores, you have a bunch of people that you give a bunch of different tests, you put all their scores into a computer, and it does some very complex mathematics, and it does something called a factor analysis. It looks at how all these tests intercorrelate amongst each other, and it extracts out certain factors, which are tests that correlate with each other. They say that a test that loads on a factor correlates with that factor, and all the tests that load on a particular factor correlate with each other. So when you do that, if you give a bunch of different tests of different types of intelligence, you will, like I said, you will see that they tend to positively correlate with each other. And when you do the factor analysis, usually the factor that comes out that accounts for the greatest amount of the variance, all of the tests will load on positively, meaning all of these tests intercorrelate with each other and therefore intercorrelate with this one factor. And they've labeled that factor G for general intelligence. So this is the idea that there is one general intelligence. And then within that, there are other sub-intelligences, if you will. The second factor that comes out usually tends to be verbal versus spatial. So the tests that are verbal in nature, such as vocabulary fluency, will correlate positively with each other, and they will correlate positively with the factor number 2. And then the other tests, visual spatial ability like mental rotation or doing mazes, will correlate with each other, and they will correlate negatively with factor 2. So everything correlates positively with each other. But then once you've subtracted out that overall general intelligence, you can find these sub-intelligences, which usually turn out to be verbal versus visual spatial. And sometimes if you have a very large sample, you can find even more factors than that, but those are the two main factors. Based on factor analysis, Thurstone came out with some primary mental abilities, which I've listed here. If you want to see more details about what each one is, you can read about it in the textbook. But he came up with these looking at how different tests intercorrelate with each other and using factor analysis. So word fluency, verbal comprehension, numerical ability, spatial visualization, associative memory, perceptual speed, and reasoning. These are the different, what he called the primary mental abilities. Other researchers have divided intelligence into fluid intelligence and crystallized intelligence. Crystallized intelligence is, it usually tends to be verbal tests, although it wouldn't have to be. It's stuff that you know or stuff that you've learned. It's kind of like stuff that's in your memory. And I'm going to give you an example in a second. Fluid intelligence, on the other hand, is the ability to actually do something, to kind of think in a certain way. So to see abstract relationships and to draw logical inferences. One example of a fluid intelligence test is Raven's progressive matrices. It's a very popular test. This is an example. This is one of the easier examples from Raven's progressive matrices. And it's not verbal, it's visual spatial. So you're shown an array of items, and you have to look at how they differ from each other going across and also going up and down, and you have to choose, it's a multiple choice test, what falls in, what should go here. So if you look going across, in each row there's a black one, a hatch marked one, and a white one. Going down, there's also a black one, a hatch marked one, and a white one. You also have a circle, a triangle, and a square. So what would go here? Well, we're missing a triangle, so we know, or no, we're missing a circle. We've got a square and a triangle. We're missing a circle. Also going across, we have a triangle and a square. We're missing a circle. So we know we need a circle, but what color is the circle going to be? Is it going to be black, white, or hatch mark? Well, going down, we have a white one, we have a black one. What we're missing is a hatch mark. So the correct answer is here, the circle with the hatch mark in it. This is one of the easier ones. They get more difficult than that. But this is considered fluid intelligence because you're not relying on your memory. You are figuring something out. You're observing a pattern and figuring something out, drawing an inference. A couple of examples of crystallized intelligence. Vocabulary is a good example of that, knowing the definition of words. So, for example, what is the definition of penultimate? Knowing the definition of words is crystallized intelligence. It's something you've learned and kind of it's stuck there in your memory. Another example would be, how far is it from New York City to London? Another thinker in the field of intelligence is Robert Sternberg. He's been very influential. And he has argued that there are three basic kinds of intelligence. Analytic intelligence, or problem solving, which is what most intelligence tests actually measure. But then he points out, in addition to that, that's important, but in addition to that, there are other types of intelligence that the traditional intelligence tests don't measure. And he believes the other two important ones are creative intelligence, that is the ability to come up with novel solutions, to think of new things other people haven't thought of before. And also practical intelligence, which is kind of your everyday intelligence, or what you might call your street smarts. So these are just some examples of things that go into these different types of intelligence. So analytical is what is often measured on intelligence tests, so your ability to analyze, to critique, or judge, and things like that. Practical or street smart intelligence is more your ability to apply what you know, to get around and interact with other people and get along in your everyday life. And then creative intelligence is being creative to create or invent new things that other people haven't thought of before. And finally, another influential thinker who also believes in multiple intelligences, but he's a little bit different from Sternberg. Gardner actually believes there are more intelligences, and he has come up with his theory based on just observing many different types of people and giving them different types of tests and see how they intercorrelate with each other. And he also, one thing that's kind of different about his theory is that what constitutes an intelligence can change over time. So part of what defines an intelligence is what your society or your culture thinks is important, an ability that is valued by your culture. So it can vary across cultures, and it can also vary over time. And he originally came up with 7 different types of intelligence, and he has recently added another one. There's a lot of other researchers out there who think that there are other types of intelligence that should be added to the list. But his types of intelligence are linguistic or verbal, logical, mathematical, spatial, musical, bodily kinesthetic. Somebody who's good, who has high bodily kinesthetic intelligence would be somebody who has good control over their body, so they would be good at sports or possibly a good dancer or something like that. Interpersonal, ability to get along and understand other people. Intrapersonal, ability to understand yourself and to have self-control. And then finally, the one that was added later, naturalistic, ability to see patterns in nature. So somebody who is a good botanist or a zoologist would be good at naturalistic intelligence. And I just wanted to say a little bit, you've probably heard of emotional intelligence. About 20 years ago or so, the idea of emotional intelligence became very popular as kind of a counterpoint against the traditional theory of the more analytical intelligence. And I'm going to give you an example of emotional intelligence in the next slide. But under Gardner's theory, what we call emotional intelligence would be a combination of the interpersonal and intrapersonal. So emotional intelligence is ability to understand emotions, both your own and other people, and to understand how other people are thinking. So here's an example of a couple of different items from an emotional intelligence test. The first one is pretty much nonverbal. You just show somebody a picture of a facial expression and ask them, what is that person feeling? And then the second example is a more verbal example. You would describe a situation and then ask them, what is that person feeling? So in this one, it's Tom felt worried when he thought about all the work he needed to do. He believed he could handle it if only he had the time. When his supervisor brought him an additional project, he felt blank. And then you would need to select what the correct answer is. The correct answer to both of these is A. Okay. So that is my little mini lecture on intelligence, and I hope it helps you to understand the chapter better.